This is a video about innovation in the consumer electronics and how it has had an adverse effect on the environment. Consumer electronics, also known as home electronics, are electronic equipment which we use in our everyday life. We are surrounded by them, be it television sets, video game consoles, laptops, mobile phones, printers, refrigerators, or washing machines. Global consumer electronic market was valued at around $1,172 billion in 2017 and is expected to reach approximately $1,878 billion in 2024, growing at a CAGR of above 6%. The innovation started when the first radio equipment was built in 1894. Then we got the radio broadcasting in the early 20th century, giving us the broadcast receivers, and in 1933 we got the FM radio. Then we got the television in 1927, but it only picked up pace in the 50s. The industry was revolutionized when the first working transistor was invented in 1947. This invention led to transistor radios, which further led to the emergence of the home entertainment consumer electronics industry. Sony successfully commercialized transistor technology for a mass market in the 50s. In 1959, MOS transistor was invented and revolutionized the industry. It has been the building block of modern digital electronics. During the late 20th to the early 21st century, MOSFET was invented, which helped with submicron levels, and then nanoelectronics in the early 21st century. The increase in consumption of electronics has two major adverse ecological effects. First, it significantly increases mining and procurement for the materials needed for production. And second, discarded devices produce quantities of electronic waste. Many consumer electronics contain toxic minerals and elements. In 2016 alone, 44.7 million tons of e-waste was generated, out of which 3.9 million tons was contributed by the small IT. Do you remember what you did with your first, or third, or the fifth iPhone? Well, US spent $206 billion on consumer electronics in 2012. Only 29% of the resulting e-waste was recycled. The rest was simply trashed. We generate about 50 million tons of e-waste every year. This is equivalent to throwing out 1,000 laptops every single second.
The health effects of electronic waste are undeniably devastating. The toxic contaminants can lead to birth defects and ultimately death. Who is to blame? Consumers certainly have a role to play in the increase of e-waste. They are buying the goods after all. Manufacturers have given people fewer and fewer viable ways to keep older electronics functioning effectively. The largest producer of e-waste is Asia. Canada and USA are huge consumers of devices, and while they do have legislation to recycle e-waste, they still end up in landfills. We can classify the approaches to tackling the e-waste problem under adaptation and mitigation. Adaptation tactics can be broken down into reduce, reuse, and recycle. Change is required in consumer attitudes, which can lead to manufacturers abandoning planned obsolescence practices. Consumers are aided in the process by rating systems such as EPA-EAT, which gives information they need to choose products that reduce the threat of e-waste. Governments are developing regulations around hazardous chemicals such as restriction of hazardous substances in electrical and electronic equipment, REACH, Electronics Watch in Europe, and SPLC in US. These initiatives encourage large-scale purchasers to prioritize sustainability in their product choices. The IEMEI, an industry association, is looking at safer alternatives to the toxic chemicals present. There is a demand for second-hand refurbished phones. Companies like iFixit and Close the Loop repair and resell phones. The US EPA convened a multi-stakeholder process to create a voluntary, market-based mechanism for ensuring best practices in responsible electronics recycling. What emerged from that process was the R2 standard, and later renamed as Sustainable Electronics Recycling International, or CERI. Roninate in Canada has developed a process which grinds metals from electronics underwater and uses ultrasonic energy to separate the metals from plastics for further processing. UNSW has designed an electronic recycling microfactory. Most consumer electronic companies have adopted recycled materials in their products, packaging, and are using alternatives to toxic chemicals, implementing new tools and policies. Innovations can change the way electronics are manufactured. Ahead of Earth Day in 2018, Apple debuted a new robot named Daisy that can take apart iPhones in order to recover valuable materials inside. Manufacturers are considering using sustainable new and recyclable materials such as aluminum, a green metal used in electrolytic capacitors, polymers, borosilicate glass used in electronic tubes, optoelectronics, graphene, which can be used in faster transistors, and bendable phones to improve touchscreens and advanced circuitry. Biomaterials such as silk, due to its biodegradability and biocompatibility. Wood as outer casing of electronics. Biodegradable resins used in sensors, even implantable and digestible electronics. Lastly, innovations in self-healing electronics can prolong the life of the products. In the end, we ask that stakeholders in innovation ecosystem across industries, markets and regions consider the long-term impacts and sustainability in the ideation stage of innovation process itself.